we're going to do a problem from the back side of the first sheet. It's the very last question, I think. Question 10. There is a typo. So if you have it and you see it saying 6 squared, it should actually be 6x squared. So let's quickly change that, and then we'll talk about how you go about this kind of problem. So 6x squared plus 16x plus 8, and we need to factor that. We're looking for, initially we might be looking for two numbers that multiply together to give 8. But if you look at the beginning term here, the number in front of the x squared is 6, which means that if I factor it directly into two binomials, I've got a lot of different possibilities. The first term in each one, these two numbers multiply together to give 6, or the first two terms multiply to give 6x squared. So they could be 6x and x, they could be 3x and 2x, and also this number here, 8, I've got possibilities for that as well. I've got 4 and 2, 8 and 1, so I've got a lot of different combinations. But if you notice, everything is a multiple of 2. They're all even numbers. So I first start by pulling out that common factor. And this is something you should always look for. A common factor, if you pull it out, will always make your job easier. So if I pull out the factor of 2, that leaves me with 3x squared plus 8x plus 4. And now my job is a little bit easier because I have numbers at the beginning of each set of parentheses that multiply to give this 3. So really the only two choices are a 3 and a 1. So I have a 3x and an x, and I know that my first term will be 3x times x, which is going to be 3x squared. This 4 I get, well, from 4 times 1 or from 2 times 2. So in the second part of the brackets here, I could have a 4, which would give me a 1 over here, a 1, which would give me a 4 over here, or a 2, which would give me a 2 over here. So I've got 3 different pairs that could work. So let's go through and see. If I put the 4 in over with the 3x, that means I need to have the 1 over here. I'd get 3x times 1, which is 3x. I would have the 4 multiplying by the x, which would give me plus 4x, and that gives me 7x for my inner and outer terms, or outer and inner terms. I need to get 8x, so 7x is no good, so this is not the right way around. The next possible combination is a 1 in here and a 4 here. That would give me a 3x times 4, which is 12x. This seems really high. I would have a 1 in here plus 1x, which gives me 13x for my middle term here. Again, 13x, not 8x, so that's no good. So it's not that. So really, I'm left with the 2 and the 2. Again, we can see they multiply to give plus 4. They add to give plus 8. We're going to assume that all terms are positive. So we have 3x plus 2, x plus 2. I still am not convinced that this works, but let's see what happens if I FOIL it out. Again, I'm just going to kind of forget about this 2 for a minute. I'm just going to look at the first and second set of parentheses here. So with the 2 and the 2, I have from my first term, I have 3x squared. From my outer, 3x times 2 gives me 6x. My inner, 2 times x gives me 2x. And my last, 2 times 2 gives me 4. So I have 3x squared plus, and these you can see combine to give 8x. So that's good, plus 4. So my guess here checks out. I can just quickly double check as well that this 2 makes everything look good. If I kind of multiply in the factor of 2, although it's at the front here, I can put it at the end. I end up with 6x squared, which checks out as my initial term at the top. Plus, this combines to 8x multiplied by 2, gives me 16x. This checks out as my middle term at the top, plus 8, which again checks out as my final term. So the answer, you can see here, let's just clean up some of my workings a little bit and we'll put a box around it. The factored form of this polynomial is 2 times 3x plus 2 times x plus 2, and that is my answer.